Hi, this is Alex from devstories.eu, Docker Masterclass, episode 14 of 18. You are mid-conversation with an AI coding engine and you ask it to query a database. Normally, if you forgot to configure the database tool beforehand, the agent fails and asks you to intervene. The problem is manual tool configuration breaking the flow of work. But what if the agent realized it was missing a capability, searched a catalog, and installed the necessary server entirely on the fly? That is exactly what Dynamic MCP auto-discovery accomplishes. Typically, providing tools to a large language model means statically defining them in a configuration file before you start the session. If your agent might need to read a GitHub repository, post a Slack message, and query a database, you have to load all those model context protocol servers up front. This approach clutters the context window with tools that might never be used and requires you to predict the agent's needs perfectly. Dynamic MCP shifts this paradigm. It allows the agent to discover and attach tools precisely when the task demands them, without any human intervention. When you enable the dynamic feature, the Docker MCP gateway exposes a set of management tools directly to the AI agent. The gateway essentially gives the agent the ability to manage its own toolchain. The two critical tools provided by the gateway for this process are MCP find and MCP add. The agent interacts with these exactly like it interacts with any standard function call. We can look at how this logic flows using a concrete scenario. Suppose you ask your agent to analyze user metrics stored in a SQL database. The agent evaluates the request, checks its current toolkit, and realizes it does not have any database querying tools loaded. Instead of throwing an error, the agent invokes the MCP find tool, passing in a relevant search string like Postgres. The gateway intercepts this call and queries the configured Docker MCP Catalog for available servers matching that string. It returns the metadata and descriptions of the matching servers back to the agent. The agent reads the description, confirms the Postgres server will solve the problem, and moves to the next step. The agent then invokes the MCP add tool, passing the identifier of the Postgres server it just found. This is where it gets interesting. The gateway catches the MCP add request, pulls the necessary image, spins up the MCP server in a Docker container, and dynamically binds the new tools to the active connection. The agent suddenly has access to the database tools, connects to your database, runs the query you originally asked for, and returns the result. The entire process happens in the background, keeping your conversation completely unbroken. There is a third tool provided in this management suite for experimental code execution, but it handles a completely different problem set, so we are keeping our focus strictly on discovery today. Here is the key insight about this process. When the agent uses MCP add to load a new server, that addition is strictly scoped to the current session. The gateway does not rewrite your global configuration files, and the newly added tools do not persist across restarts. When you close the session, the temporary tool binding is destroyed. This ensures your baseline environment remains clean and secure, while still giving the agent maximum flexibility to solve complex, multi-step problems dynamically. By exposing catalog search and installation as standard function calls, Dynamic MCP removes the burden of upfront configuration and allows the agent to build its own environment on demand. That's all for this one. Thanks for listening and keep building.